Welcome to the deep dive.
Good to be here.
Today we're taking a look at that helicopter crash, the one in the Hudson River on April 10th.
Yeah, a really awful event. Tragic loss of all 6 people on board.
Just terrible. What we want to do here is try to understand, what might have happened. We're basing this on a really thorough analysis we found. It was a YouTube video transcript by Blancolirio.
Yes, and it's quite detailed. Uses publicly available data, ADS-B tracks, photos, videos.
Yeah.
And the presenter clearly has a background in aviation, helicopter mechanics specifically. It gives us a solid starting point.
Okay, good. So let's start with the aircraft itself. What do we know?
It was a Bell 206 Long Ranger, owned by Meridian Helicopters, down in Louisiana, I think.
That's right, but operated by New York Helicopters for these tours.
Right. Tail number N216MH was a 2004 model.
And it had racked up quite a few hours, hadn't it? About 9,600.
Yeah, around 9,600 flight hours, which, for a 2004 commercial helicopter isn't necessarily extreme.
Okay, so maybe not immediately screaming old age fatigue or anything like that.
Not necessarily on its own, no. Assumes, of course, that regular, proper maintenance was being done all along.
And it was operating under specific rules, FAR Part 135. What does that tell us?
Part 135. That's significant. It means it's certified for charter operations, like these tourist flights.
So stricter rules than, say, my buddy flying his own little plane.
Oh, yeah, definitely. Higher standards for maintenance, pilot qualifications, operational procedures. It's all meant to ensure a higher safety level for paying passengers.
Right, makes sense. And the flight path itself, pretty standard tourist loop, wasn't it?
Totally standard. Depart from downtown, circle the Statue of Liberty, head up the East River side, maybe towards the George Washington Bridge, then back down the west side along the Hudson.
A flight thousands probably take every year.
Exactly. And what's striking is the ADS-B data, the tracking data. Shows everything looking completely normal. Altitude, ground speed, all standard right up until the incident near the Holland Tunnel Bridge area.
No sign of trouble there. And also no sign in the communications, right? No distress call.
None whatsoever. The ATC recordings just have the pilot making routine radio calls at the usual VFR waypoints. Abeam the Intrepid, things like that. The last one was totally normal.
That lack of a call, it really points to something sudden, doesn't it?
It strongly suggests whatever happened incredibly fast, catastrophically fast. No time for the pilot to even key the mic, it seems.
Yeah. Now, there were some early reports about fuel. Something about the pilot asking for more fuel.
Right. The CEO of New York Helicopters clarified that. Apparently, the pilot had requested more fuel, but it was for future flights, planning ahead. Not an indication of being low on fuel during that specific flight.
Okay, so we can probably set aside fuel starvation as the immediate trigger here.
Seems very unlikely based on that clarification.
Yeah.
It pushes us towards looking at a mechanical issue.
Okay, so let's get into the helicopter itself. The Bell 206, it uses a two-bladed semi-rigid rotor system. Can you break that down a bit? What's semi-rigid?
Sure. So semi-rigid refers to how the two main rotor blades are attached to the hub. They're connected in a way that lets them flap up and down together, kind of like a seesaw, pivoting on the mast.
Okay.
This design gives it good stability and control. It's different from, say, a fully articulated system with more hinges, or a teetering system like on some Robinsons, which can be more susceptible to something called mast bumping under certain conditions.
Okay. We'll come back to mast bumping. And these blades connect to the transmission through V-shaped beams.
That's right. Those beams, sometimes called pitch links or grips, depending on the exact setup, transmit the forces and control inputs to the blades and handle the immense aerodynamic loads. They connect the rotor hub, which is driven by the transmission, to the blades themselves.
Gotcha. Now, the transmission, this seems really central to the analysis we're looking at. What's going on inside there? It's pretty complex, I imagine.
Oh, absolutely critical. It's not just a simple gearbox.
Yeah.
Inside, there's usually a sophisticated planetary gear system.
Planetary gears, like in a car's automatic transmission.
Sort of, yeah. Similar principle. Multiple smaller planet gears revolving around a central sun gear, all inside a larger ring gear. Its main job is to take the super high rotational speed from the turbine engine, we're talking tens of thousands of RPM, and reduce it way, way down.
Right, down to the few hundred RPM the main rotor actually needs to spin at to create lift.
Exactly. It's a massive reduction, handling huge amounts of torque. And there's a drive shaft connecting the engine to that transmission, and usually another drive system going back to power the tail rotor as well.
So clearly, if something goes wrong in there, it's bad news. What warnings should a pilot get?
Well, there are several layers of safety built in. First, you've got gauges in the cockpit for transmission oil pressure and oil temperature.
Standard stuff.
Right. If pressure drops or temp spikes, that's a major warning sign. Then you have oil filters to keep the lubricant clean. But critically, you have chip detectors.
Chip detectors. Okay, the video analysis mentioned these. How do they work?
They're basically magnetic plugs placed strategically in the oil system, inside the transmission casing. If metal parts inside, like gears or bearings, start to wear or break down, tiny metal particles flake off into the oil.
And the magnet catches them.
Exactly. The magnet attracts these ferrous particles. If enough metal particles build up on the detector, they can bridge an electrical gap, completing a circuit and illuminating a warning light in the cockpit.
So it's like an early warning system for internal damage.
That's the idea.
Yeah.
It's supposed to give the pilot advance notice that something is starting to fail internally, giving them time to, land as soon as possible before catastrophic failure.
Which makes this incident, well, deeply concerning. Because it seems like that warning didn't happen or there wasn't time to react if it did.
Precisely. That suddenness is a key part of the puzzle the NTSB will be digging into. Why no apparent warning before such a total failure?
Okay. Now, about that online speculation, mast bumping. We touched on it, but the analysis seemed pretty dismissive for this helicopter type. Why?
Right. Mast bumping is when the main rotor hub actually hits the rotor mast it's mounted on. It can happen, especially in helicopters with those fully teetering rotor systems I mentioned, often during low-G maneuvers or sudden control inputs.
Like pushing the stick forward abruptly?
Yeah, or in severe turbulence. But the Bell 206's semi-rigid system, where the blades flap together, makes it inherently much less susceptible to this. It's not impossible, but it's considered quite rare in a 206 compared to some other designs.
So while people might talk about it online, the mechanics of this aircraft make it less probable?
That's the assessment and the analysis, yes. And it really highlights why we need to wait for the NTSB and look at the actual physical evidence.
Definitely. Which brings us to maybe the most significant observation from the video analysis, the main rotor system.
Yes, the fact that the entire main rotor, assembly blades, hub, and the transmission was seen separating from the fuselage and then auto-rotating down on its own.
Auto-rotating.
Yeah.
Meaning it was still spinning from the airflow, allowing a somewhat controlled descent, even without engine power.
Correct. For that whole assembly to auto-rotate relatively stably like that, it means the blades were intact, the hub was intact, and crucially, the transmission was still attached to the rotor mast and hub. It came off as one big piece.
That's... wow. Okay, so what does that tell us about the failure?
It strongly suggests the failure point wasn't the mast breaking above the transmission, which is often what happens in severe mast bumping. It points towards a failure at or within the transmission itself, causing the entire unit to detach.
The video analysis looked closely at footage of the breakup itself, right? What did that seem to show?
Yeah, based on the available, somewhat grainy footage and stills, the sequence appears to be normal flight, then a sudden, violent internal event. The helicopter starts to spin, and parts begin separating.
And the analysis suggested the main rotor and transmission assembly likely went first.
That seems the most plausible interpretation based on the visuals. The main rotor transmission unit separates, and then other parts, likely the tail boom and tail rotor, break away almost immediately after, due to the sudden imbalance in forces.
And the cause proposed in the video was a sudden seizure inside the transmission. They used that analogy.
Putting a stick in the spokes of your bicycle. Yeah.
That's a vivid image. Why is that fitting here?
Because it captures the instantaneous, catastrophic nature of it. If something inside that transmission, a gear, a bearing, suddenly locked up solid while everything is spinning under immense power, the forces would be unbelievable.
It wouldn't just grind to a halt. It would basically tear itself apart.
Instantly.
Huh.
The inertia of the rotor system and the power from the engine fighting against the sudden blockage, something has to give structurally. It would lead to the kind of rapid disintegration and separation that seems to have occurred.
The analysis also noted something about the condition of the recovered rotor. No tail boom strike. Why is that significant?
It's another piece of the puzzle. In many accidents where control is lost or there's a rotor system failure, the main rotor blades end up hitting the tail boom as the helicopter tumbles.
Right, you see that damage often.
The apparent lack of that kind of strike damage here reinforces the idea that the failure was extremely rapid and contained within the main drive system. The rotor assembly likely separated cleanly before extensive flailing and secondary impacts could occur.
And it's worth stressing again, this isn't something you expect to see on a Bell 206. The video analyst said it's extremely rare.
Extremely rare. They mentioned maybe only knowing of one or two potentially similar incidents over decades of experience. This model has a generally excellent safety record regarding this kind of catastrophic transmission failure.
So given that rarity, and given the chip detectors should warn of developing problems, what could possibly cause such a sudden seizure without warning?
That is the million-dollar question for the investigators. It could be a flaw in a component, perhaps something microscopic that wasn't detectable during manufacturing or inspections, that finally let go under stress.
A hidden defect.
Possibly. Or maybe a very specific type of failure inside that happened so fast it didn't shed enough debris before the catastrophic lockup. Or perhaps a sudden, complete loss of lubrication, although usually you'd expect the pressure warning light first in that case.
Lots for the NTSD to look into.
Absolutely. Metallurgical analysis of the failed components will be key. They'll be examining the fracture surfaces under microscopes, looking for the origin point, signs of fatigue, heat stress, material defects.
And they'll be digging into the maintenance records too, I assume.
Oh, definitely. They'll scrutinize every logbook entry. Was all scheduled maintenance done? Were there any recurring write-ups related to the transmission, vibrations, chip lights, oil consumption? Any recent major work done on it? They'll be looking for any red flags that might have been missed.
Right. One other detail mentioned the flotation devices. They weren't inflated during the crash sequence, but were deployed later.
Yes. The analysis suggested these likely deployed automatically on contact with the water. Many helicopters certified for overwater flight have these systems. Sensors detect water immersion and trigger inflation.
So the pilot wouldn't necessarily have had to activate them?
Correct. In a sudden event like this, the automatic system is the backup. Tragically, it wasn't enough here, but it's an important safety feature.
And just to close the loop on mast bumping one last time, the state of the recovered rotor assembly really argues against it.
Yes, that's the key takeaway from the analysis regarding that theory. Classic mast bumping usually breaks the mast above the transmission. Seeing the transmission still firmly attached to the auto-rotating rotor system points away from mast bumping and towards a failure originating within or at the transmission itself, causing the whole unit to separate.
Okay. So wrapping up the main points from this analysis, it looks like the most likely scenario, based on the available evidence right now, is a sudden, catastrophic mechanical failure,
Yes, originating most likely within the main transmission.
leading to that incredibly rapid separation of the entire main rotor and transmission assembly from the helicopter.
That appears to be the strongest hypothesis based on the visual evidence
Yeah.
and the known mechanics of the aircraft, according to this analysis. But again, crucial to stress, this is preliminary.
Absolutely. The NTSB's official investigation is what counts, and that will take time to reach definitive conclusions.
Their detailed examination of the wreckage, the maintenance history, the operational data, that will provide the final answers.
Still, it's just sobering to hear how unusual this type of failure is considered for a Bell 206.
It really is. It underscores why this investigation is so important. If there's a previously unknown failure mode or a potential issue with certain parts, the entire industry needs to know.
Of course. And our deepest condolences truly go out to the families and friends of the 6 people who lost their lives. Just an unimaginable tragedy.
Absolutely. A devastating loss. Our thoughts are definitely with them.
And it leaves us, as we finish this deep dive, with a really troubling thought, doesn't it? You have these safety systems, the gauges, the filters, those chip detectors, all designed precisely to warn about developing problems in something as critical as the transmission.
Redundancies built in.
So what kind of perfect storm of factors, what unforeseen chain of events could possibly lead to a failure so abrupt, so total, that none of those warnings mattered, that the pilot seemingly had zero chance to react? It really makes you think about the limits of mechanical prediction and the immense complexity we rely on every time an aircraft takes flight. Something to ponder. Thank you for joining us for this deep dive.